Alright, draft science video, yay. I had some thoughts about wavelength and frequency that I probably want to get to, and I'll see if I get to it through some of these comments. So some guy did leave some comments, so I'll respond to those. I already posted a link to the Feynman section because he brought up Feynman dispelling this idea of a pressure, photonic pressure being responsible for gravity. And I'm going to include as a reference link, in my further what I post, a link to a Wikipedia page on Lesage's theory of gravitation. But there's been a lot of people that have, reworked this idea. But clearly, I think I'm the first person to be reworking it in the context of this being an interaction not between matter and energy, but between energy and energy. The energy in the matter. So the stuff is already moving the speed of light in the matter. And that's what makes all the difference, in the sense that there is no conversion. You're not converting energy. All you're doing is changing angular momentum. So in a sense, you're just conveying it. It's like the exchange you can make with a gravitational body, in terms of, if you're a spaceship, you can fall into the gravity of a planet and use the gravity to turn your spaceship in a fairly lossless manner. No one loses energy in the process. There's an exchange, and the two bodies end up changing their momentum. They change their direction, but nobody loses any energy. You don't release any energy. There's no heat. There's no consequence. It's an efficient transfer of momentum. So that's quite possible in this nuclear circumstance, especially with, like I said, photons. I think photons, all their interactions are kinetic, completely kinetic, in the sense that all the energy is converted instantaneously in the interaction. They're doing the pool ball thing in a very real way, in the perfect way, and there just isn't any heat or friction or there's no byproduct of the process. And that's obviously, I think, it's obvious that gravity works that way in a sense, because we obviously don't see any diminishment of it, we don't see it exhausted, we don't see it creating a heat problem, all of those things. So I guess the key thing to recognize is from a light beam's perspective, there is no such thing as momentum. Nothing has momentum. From its perspective, there's just a bunch of other photons moving the speed of light. It doesn't even have to recognize the existence of matter. Matter doesn't matter to photons, in the sense that it's just seeing the fish. So again, we're back to this analogy, but I think it's a valuable analogy. A fish entering a school of fish sees fish, doesn't see a school of fish, and it interacts with individual fish. It doesn't interact with a school of fish. And it's just an important distinction. Alright, so let's start at the bottom, work my way up. Filter do not change polarization. They remove objects that fit a certain criteria. No, I'm just saying, with polarization of light, I don't want to get into an argument here. The polarization I was using for the purpose of this, for the magnetism thing, is just the realization that there's this form distinction where you can call it polarization, or you give it some other title, where it has two states. Okay, and polarization is kind of a two-state thing. Okay, it's this crossbar thing. There's the two states are vertical and horizontal. They're the two extreme states, and it can be in any configuration around that, but I'm just saying those are the two extremes. Is something that creates the 90-degree angle is the marker for the extreme. Anyway, the remove objects fit the criteria. That external pressure, gravity, has been invalidated a long time ago. Well, again, you say it's been invalidated. I say it hasn't, rationally. Feynman discusses it in one of his lectures. Again, I played the clip in my video, so you're not even watching all of these videos. And, I mean, why don't you say that before you even comment? I haven't watched all these videos, but I'm going to critique what's being argued. Right? I mean, I couldn't make it more overt. I played the Feynman clip. Okay, so, I mean, I can't call you an asshole for this kind of bullshit. So yeah, I've dealt with the Feynman argument. It's a bogus argument. Quite obviously, anybody who's going to say there's the idea of a pressure, that would be creating gravity, a photonic pressure, and the shadowing effect. Anybody making that argument would already be a stipulation that momentum has nothing to do with it, because then obviously the Earth is moving, in an orbit, and then there would be more gravity on one side of the Earth than the other side of the Earth, because the Earth is moving. So anything moving would be suspect to this gravity problem if it existed. So quite obviously, gravity doesn't pay any attention to momentum. It doesn't care how fast you're moving. Your gravity is going to be exactly the same. So that's not even it's not a valid argument from a premise of the theory itself. The theory is already stating as a rule, okay, that quite obviously gravity doesn't acknowledge momentum. Quite obviously. Shit. So I mean, it's just for Feynman to dismiss it on the grounds of momentum issues, it's just so bogus. There are no two extremes in polarization. Well, again, you say so. I'm saying this and this are extremes. Polarization basically works by putting bars in the way, and only the stuff that can fit through the bars can get through the bars. That's how it works. So I'm just saying, I don't think that's a valid argument. Of course there's two extremes. It depends on your base system. Obviously for light polarization, the base system is vertical versus horizontal kind of a thing. I can have polarization of a wide circle that is equivalent to a magnet with a pole of 45 degrees or 60 degrees north, or 0 degrees south is 90, question mark, I don't know. But that, I'm not, never mind, I don't even want to waste time with that because I can't understand it and I don't really want to bother. I'm sorry if you misunderstood me, if I said it poorly, but I think I made it clear in the video. I did say, I'm not saying this polarization is the same as light polarization. I was just using the idea of state changes as a valuable thing. Something can be in an on state or an off state. That's all I was saying. The ring should go from north to south where the poles are in your magnets. Where are the poles? Yeah, well, I tried, that was probably my bad. Because I was thinking about the idea that magnets tend to have a south side and a north side and a north end and a south end. But that's not really true. I guess they technically just have the two poles. It just appears like they have a side that is south. But that only matters depending on which way the other magnet is, right? So if it's north to south or south to north. So I'm just saying, but for the purposes of my description, I'll do it a third time to do it right. But for the purposes of my argument, it just makes it even simpler. So I did have the magnets in an up and down configuration. I had them literally with an N and an S. So that part is still valid. I just created a bigger middle, and that probably wasn't necessary. But again, it just makes my argument even more valid if I just separate it into 2 poles instead of 4 poles. So it doesn't, your argument doesn't change anything. Sorry, but you should use a few more formalized approach. Even Star Trek could explain everything with vague descriptions. Yeah, well, obviously they weren't explaining light speed with any description whatsoever, anything reasonable. Alright, 12. Superconductive materials exist. I didn't deny the existence of superconductive materials, so why? How do you explain the movement of electrons in a vacuum in a magnetic field. But we know a vacuum isn't a pure vacuum in the first place, so it's kind of hard to evacuate electrons from, it's hard to move them with something if they're not attached to anything. But anyway, that doesn't even matter. Even if we presume a good vacuum, the movement of electrons is again just because you're pushing electrons. That's all. Once you liberate them from where they are, if they're in a state, they're usually there for a reason. They're usually attached to something. But let's just say they're somehow free floating with no momentum, which doesn't sound reasonable, without being attached to anything. That doesn't sound. How does an electron stop somewhere, right? I mean, theoretically, it doesn't sound like a viable concept that an electron would have no momentum, that it wouldn't be moving from somewhere to somewhere, or be knocked off of someplace. It doesn't. Electrons just don't show up and sit somewhere. They don't just like poof. Oh, there's an electron sitting there on the table. No. So somehow they have to be forced to be in a stable position. They can't just have one without being attached to something. So again, I think the magnetic field is pushing them by releasing them from their weak bonds to some other material, maybe another electron, who knows, or whatever, the anti-electron. It gets released from, and that releasing forces it to find a new home, so to speak. So it migrates in the direction of it's been pushed, and it migrates till it finds somewhere else to rest, somewhere else to attach. And now it's basically taken, it's like musical chairs. Once the electron takes a seat, then the electron that was going to use that seat, like a shared electron in an atom, now can't be a shared electron anymore. And so its bond got all weak, and so now it's going to fly off. And it's going to find somebody else's seat. And then that electron will have to find a new seat. And so that's the initiation of the current, is just a creation of a musical chair problem, where there's insufficient chairs for the number of electrons. Yeah, I think that's a good enough way to explain it for the purpose of this. The depth, I shouldn't have to go any deeper than that. You should be getting the point. How am I on the drag thing? Now we're down here. What about non-magnetic metals? They do not want to become magnets. Copper, for example. Well, I was being loose with the language. I mean, obviously they don't want to do anything. I just meant it in the sense that just as the metal filings line up, there's this tendency for, I think, in conductors, for that to start happening, where everything starts to line up. And so I think the difference between something that becomes magnetic and something that doesn't is that things like copper and other metals become magnets for very short periods of time. So they have a structure where the atoms can all start lining up, to create a magnet, but that they're too flexible. So that means the atoms twist back, or they are bent back by these photonic forces. This pressure that's all around all the time creates enough noise where they go back to their chaotic position instead of the rigid position. So they don't stay in a magnetic position. Something like that. But it's not even necessary to the point. That was just something I was throwing in as a, I think it's just true of these conductors that are not magnetic. I think they want to be, but they just can't be. I was just getting to that kind of point, that I think they're building towards being magnetic, but they can't hold the magnetism. Maybe that's a way to say it. They can't hold it. But it's not a point that's at all necessary to this idea of what's happening to electrons, which is they're just being pushed one chair at a time. They're not being pushed a long way. They're just being pushed off of a chair. That's all they're doing. They're just being pushed off of a chair. And it's just that little push that creates a consequential chain reaction. That leads to more distance than the push that went in. I guess you could argue it that way if you wanted to, you know, you give them a little bit of a push and they have to jump the full 10 feet. It's like they can't, it's like they're on pedestals and you knock them off the pedestal and they'll slide down the loop and pop up on another pedestal. You know, but they'll do a little extra distance, more distance than your push initiated. So that's why it has the appearance of giving you more bang for the buck that went in. Alright, here you go. So this is the Wikipedia page on this, you know, it started back in the 1700s, this theory of gravitation based on the shadowing of pressure. And they had different flaws in them because these guys in the 1700s, I mean, they didn't know the speed of light, they didn't know a lot of things. So, you know, it's really hard for them to formulate a coherent theory that answers all questions. So they had to explain things based on, well, why isn't there heat, and why isn't there this, and why isn't that. I don't have to worry about any of that because, again, photon on photon, there is no momentum issues, there's no friction issues, there's no destruction issues. Nothing's getting decomposed. There is no output of energy. There's no waste to a photon on photon interaction. This is why you need to put your ideas in formulas so you can check your predictions with the measured values. Well, again, I don't have to do any of that, but whatever. Again, you can just say, you say all that shit all you want. Again, I don't have to argue the point. It's already been demonstrated that it fits the, you know, the R squared rules of diminishing strength, that fits magnetism. It fits a lot of different things. Fit that same scenario of the distance squared being relevant to its half-life of its, you know, potency. Here is why the gravitation by push does not work. Well, see, this is just taken from the article, and this has to do with, again, a flux, they were calling it. You know, this doesn't have anything to do with the premise of my argument, which is it's not matter that's being interacted with, it's fish on fish. The pressure is made of a high frequency, highly dense, Planck constant kind of density, a very fine-grained, high-density energy. And the only thing being transferred is angular momentum. So there is no loss. It's just a transfer of direction. So if two cue balls intersect with each other at angles, at certain different angles, they will cause new angles of trajectory as they leave. But certainly you can understand it by gravity. And that's really what's happening, is that there's a, when the photons interact with each other, they're changing. What's happening is because matter moves more slowly, you know, because it has the speed of light is trapped in these orbits, is that energy goes in one direction and energy will come out in another direction, and there won't be any loss anywhere. There won't be any, nothing has to be taken from the system. And that's really the point here, is that it's a lossless imposition of angular momentum. And the argument is basically, if I was to, again, equate it to the school of fish, if the school of fish, if they're vibrating this way, this way, this way, this way, different fish, it really doesn't take any more energy for all of them to vibrate in one direction. The fact that they're vibrating in different directions, it doesn't take any more energy if they all move in one direction. And yet if they move in one direction, if they all move in one direction using just as much swimming power as they were using to go in all different directions, in all different kinds of orbits, and they all do it in one orbit in one direction, if they all go this way instead of going this way and that way, it takes no more energy. The fish don't have to eat any more food. Nothing gets changed for the fish, except now the school of fish has a tremendous amount of force in that direction. It doesn't have any force in that direction, or in that direction, or in that direction, but in that direction it now has more mass, technically, but not in any other direction. And that's the key. Mass only increases in the direction of the velocity, and that's why velocity is absolute and not relative. Because force is absolute, energy is absolute, and energy is all photons. And all stuff moving the speed of light. So yeah, I'm not going to bother reading that because that's just a clip from the Wikipedia argument. Like I said, that's a 1700s view. That's even, you know, half Newtonian even. It's not even fully Newtonian, you know, premise. So I don't really have I don't have to make an argument to a half Newtonian perception of atomic structure. We know a lot since then, and clearly we know gravity moves at the speed of light, and we also know it's perfectly possible to have frictionless, lossless interactions between subatomic particles. Alright, so I'll move on to what occurred to me today. This frequency thing with light has always been troublesome for me. I have to go through some of the formulas, and I'll do that eventually, but you know, as I'm perceiving it, you know, you have this, all right, you have this, the frequency, and then you have the wavelength. I know they use lambda or something for wavelength, but I'm not bothering with that crap. So we'll just use F and W, you know. So these are basically saying the same thing, though, right? Frequency and wavelength is basically they're equal. And they're using this frequency thing as a way of determining energy or force is being related to frequency. But the problem with that is that, you know, all that frequency, what frequency means is more happens in a hunk of time. So the real thing that has to be understood is time. So you have time, force, and frequency, and that's what's really got to be understood, is that this idea of frequency increasing force, frequency increasing force only happens if you're in a quanta of time, okay, and that time means that there has to be, you know, more than one photon. So I guess I'm sort of thinking that photons don't have a personality, you know, that they're all the same, so that you could have a radio wave, and you could have a microwave, and you could have light, and you could have a cosmic ray, and they're all the same thing, and the only thing that's changed about them is the period between when they show up. So these show up a lot in one segment of time. You know, these show up less often, and then these are even less often, and then radio waves are even less often. So it's really just about how many photons are crammed into a segment of time that is increasing the energy level. So when they talk about the energy level, you know, they say ultraviolet light has more energy. Well, it's moving 1.5 times faster in terms of its period. So there's, you know, so blue light is, there's twice as many, 1.5 times as many, okay, for a given period of time, like 1 second. You would have like 1, 2, 3, 4, 5, 6 of them here. You'd only have 4 of the reds. No, it'd be 3. There's 6, I make 7. Yeah, so for 7 of these, you only got 3 of the reds. So you know, this is blue light and red light. So that's the difference in the energy level, is dependent on the time. You have to have enough time to have a period. So you have an incidence. So as soon as you have like 4 incidences, it'd be 4 to 2, kind of a ratio. You know, 4 to 1.5. Oh, fuck. Yeah, 1.5. You know, it'd be 5 to 2, I guess. As a ratio. So the blue light is more intense only because there's more of it. And so what I'm thinking now, so this is sort of a draft segment, okay? This is just what I'm thinking. Sorry, this camera's it's getting hot. Is that you know, when photons are captured in matter, what's happening is that all of this, you know, cosmic ray, microwave, X-ray, all those ray kind of things, all this period stuff disappears. And when photons are in matter, their period is 0. Their wavelength is 0. I mean, you know, it could be some tiny infinitesimal number. So we could say it's the gravitational constant. I mean, that's a really insanely small number. So we could just say it's the gravitational constant is what's between them. So the photons have a perfect efficiency in that they don't have any wavelength. So if you hit one here kinetically, you'll get an output here, you know, just directly. I mean, it's just instantaneous in a sense because there's no wavelength, there's no space between them, and so they have a maximum efficiency. And it's only because these processes that create photons are electron processes. So let's say this is an electron, and that this electron is made of, you know, 2 spirals of photons, you know, in a double helix. So I try to draw that in a way you can see it progressing through space. You know, but I mean, so in this, it's spinning in this direction. So these are spinning this way around each other. So they're using up their speed of light, spinning laterally at the same time going this direction overall. So they're going in a direction but spinning around each other. But anyway, let's just say that's what it's made out of. But they're all right next to each other. There's no wavelength in any of these photons. So they could be anything. They could be radio waves. They could be anything. But how they're being released is completely dependent on the size. So it's the size of this electron. So it's really the energy level of an electron that's going to decide what kind of light or what kind of photon is going to be released. Because what's going to happen is some energy will go in, you know, maybe it has to go in this way, you know, in the same direction that it's moving. And then it's going to be released as this little tail, when it finally spins around, this little tail will be flipped off and go off in a direction. So something will come in, there'll be too many photons in the electron, and it will just release the tail end of whatever it's got. You know, but it's going to release them on its spins, maybe in the Planck constant, maybe on some other constant. But it's going to release them, let's say, in a manner where it's like the light we do see. It just keeps coming. You know, there's photon after photon after photon. So what seems obvious is energy comes into an electron, and these photons are released at exact intervals. So that's what's defining the frequency. So that's defining the color of the light, is the distance between the photons, and the distance between the photons and their release has to do with the function of the electron and the speed reduction of its spin. So let's say this helix has to spin around 1 complete revolution before a photon can fly off. And then it spins another revolution, and then a photon flies off. And then it spins another revolution, and a photon flies off. So that would give you your frequency, because it has to wait for that period to complete. And so the period of this, the thickness of this structure of the electron could be deciding what frequency light is produced. So I'm just saying there could be numerous mechanisms in the atom that's creating this. This is why I'm calling this draft, is because you could explain it as being a function of the size of the electron itself, the length of it, or it could be a function of the structure inside the electron and the fact that it's also spinning, and that spin is going to determine frequency of the release of the photons. So basically you have photons of no frequency inside the matter and frequency outside of matter because of the way they're released individually. So they could be released as a radio wave, they could be released as cosmic ray, they could be released as an X-ray, and it's just how often they're released that will decide which one of those things it is. And so I think that's a viable way to look at this. I think there's another advantage because it sort of explains how mass is energy compressed. I mean, it sort of gives you this idea of the fact that you can really, this is just like an obvious compression of the mass, because you're taking out all this wavelength space, and the wavelengths can get really quite large. So you're getting rid of all that empty space between the photons, and so you could compress a lot of energy in a very small space because you're taking out all the empty space between the incidences of the photons. So it's like if it was a checkerboard, their frequency would be like having, you know, many spaces between checkers, like a lot of space, 5 spaces between every checker. And you can imagine that, you know, to accommodate 1,000 checkers, you'd need a lot of spaces. But if you take away the distance between the checkers, now you only need 50 squares. So you need a much smaller board to accommodate the same number of energy corpuscles. Yeah, I like that. But that's what everything's made out of. It's energy corpuscles. There's corpuscles of energy. We generally call them photons, but there would be anything moving the speed of light. And those corpuscles are energy. They are the checker moving on the board. And it's all about their movement. That's the grounding of the universe. That's the fundament of the universe. And forces can interact with those corpuscles, and in interacting with them they can do so very kinetically, which means no release of extraneous extra energy. They already are energy. You can't reduce them into anything finer. They can't reduce any, they can't be reduced. And you know, all you're going to do is basically, all you're doing is exchanging momentums. You're taking directionality information and just changing it. So something comes in this way, it goes out that way, and the byproduct is it made this go that way. So it gave this momentum. In exchange, it took the old momentum. And so it makes a fair exchange. So this was going that way. This hits it. Now this is going that way, and this is going that way. I mean, it's just an exchange of direction. And that can be done losslessly, or without any energy in or energy out as a consequence. It's just a pure exchange of what is called angular momentum. Alright, I think that's enough of a video. So anyway, yeah, I'm liking this. Yeah, I'm liking it. So anyway, this thing with frequencies always bugged me. You know, this, you know, what distinguishes blue light from red light, and the idea that nothing distinguishes except the period, you know, between corpuscles, seems a viable description of the reality. It's exactly the same stuff. Some of the stuff just comes in more clumps. More clumps means more energy. Less clumps, less energy. Pretty simple. I'll write the clump formula. Clump equals yeah, clump equals E. Alright, anyway, enough of that. E equals clump. People probably won't go for that. So anyway, sorry, tired. I wanted to do this earlier, but just stuff happened, so I didn't get to it. Work in the morning, blah, 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 blah. So, anyway, gotta go. Till next time.